So good morning to everyone. So today we are going to understand single particle state. But before going to discuss single particle state, we have to understand that our main goal is to understand the reciprocal lattice space, okay, and liaison in the following lectures. So this so basically in condensed matter physics there are two types of space. One is reciprocal lattice space and another is direct lattice space. Okay. So this direct lattice space, with the help of this, we just understand what are the arrangement of our atom in our crystalline structure. Okay. So basically, this direct lattice space just help us to understand what will be the arrangement of our atom in our crystalline structure. Okay. So but basically this arrangement is understand with the help of XRD pattern. Okay. And here also involve electrons. Basically these electrons are localized at this lattice site at maximum time. Okay. So this electron, when X-ray light just fall on this crystalline structure, then this electron is scattered, and and it gives just an XRD pattern. Okay. But these electrons uh, are localized at this lattice sites. So that's the reason we obtain this XRT pattern. Here also electrons are involved. Okay. But in this case we are just considering that potential energy which these electrons are experiencing uh, have a major have a major role. Okay. This potential energy led the electron to be always around this lattice site, so when XRT pattern falls, and just we obtain this XRT pattern. Okay. So in this case, so in direct lattice space, uh, electrons in this direct lattice space, this we just consider this potential energy, that we just consider some kind of localized property of our crystalline system that we want to study. Then we have to use this direct lattice space. Okay. So so basically, with the help of this direct lattice space, we study the lattice arrangement in our crystalline structure, and electrons are involved, but basically electrons are localized, we can say, due to the potential which is experienced by electron due to lattice sites. Okay. So that's the main goal, to use this direct lattice space. Okay. And we can draw with our hand in our crystal structure this xyz coordinate of our direct lattice space. Okay. Mm. So, and basically this lattice space, in crystalline structure, this lattice can be identified by some coordinates. Okay. And basically this lattice have electrons, so these electrons can be identified by some coordinates. So it's very easy to identify these lattice sites, and with the help of this direct lattice space coordinates. Okay. But in case of reciprocal lattice vector, or we can say in case of reciprocal lattice space or momentum space. Okay. We just study another kind of property of our crystalline structure. Okay. So this crystalline structure have electrons. Okay. And if we apply some kind of electric field or some kind of temperature gradient, then these electrons will move in this crystalline structure, and this electron have some kinetic energy. So it is following some kind of trajectory. Okay. So in this direct lattice space we can't draw this trajectory. Okay. We can just say that this electron have some kind of kinetic energy T1, say. So we can just we can just fix this in direct lattice space. We can just draw and or just a point, and this point signifies a stationary point, or we can say just a fixed point, and this fixed point will signify that kinetic energy. Okay. So it is not possible that a particular point will signify kinetic energy in direct lattice space. Okay. Because this particular electron have kinetic energy, so it have some direction, and it will just change its coordinates continuously. Okay. So in direct lattice space we can't just fix this kinetic energy. Okay. We can just signify this kinetic energy of electron just by one point. okay, on fixed point which is not moving. Okay, so dynamics of electrons. Okay, so these things can't be studied in right lattice space, so we have to use this reciprocal lattice space, or you can say momentum space. So in momentum space, say a particular electron is of kinetic energy, so it have some kinetic energy, but mainly due to some potentials, mainly due to some momentum. Okay, so in momentum space, say px, py, pz coordinate. Okay, in this px, py, pz coordinate, uh, this electron has some kind of kinetic energy, so it has some kind of momentum, so uh, we can just give one a fixed point in this space. Okay, and this fixed point will signify some kind of kinetic energy. Okay, so that's why people are interested to study electron dynamics in reciprocal space. Okay, and now we can clear that why it is very important, why this reciprocal uh, space is important to in order to understand electron dynamics. So so electrical conductivity, thermal conductivity, whatever be with the properties in which electron dynamics are involved, have to be studied in this reciprocal space. Okay, so now let's begin our topic, that is our single particle state.